All right, so today we're gonna get into team drill number 3. It's gonna cover a little bit of everything and get us also into registration, re-reg, and TRC. All right, right when we open it up, we'll see our data sheet. We have not only our grid, but our altitude and our reefer deflection. Everything we need to get started here. So as per usual, I like to go up to the top and just copy down the information. We'll get our grid, 1120, 8100, and I like to convert those to 10-digit grids. Get our altitude of 548, our mounting azimuth, which we are not given, so I'll just leave that blank for now, but our reefer deflection is 3200. It says that we have HE and Red Foss, the M821 and the M19. And at this point, that's pretty much all we can do to set up our board. If we wanted to, we could pull modified observed, get a GI. But as you'll see in the next mission, what we're really looking for is an observed firing chart. All right, starting with situation alpha. Alpha 60 calls up and adjust fire grid mission, gives us a grid to the target and his OT direction, saying that there's a platoon in the open. The chief gives us our FDC order, and we are instructed to make an observed firing chart. So the first thing I like to do is go ahead and compute my differences between my easting and the target easting, and then again for the northing as well, so that I can come up with the math method and apply that based on that range, whether I need to go pivot point method or below pivot point. So my target's grid is 1280, 8300, and we'll just tack on a 0 at the end to make them 10-digit grids. In this case, my target is greater on the easting than my MFP, so I know it's going to go right. Take that target easting of 12800, and I'll subtract 11200, which is our easting, to the MFP, and I get a right 1600. Then I can look at my northings. My target northing is greater than my MFP northing, so I know it's going to be an up. 8300, 0 minus 81000 is going to give us 2000. So I know from us that target is right 1600, up 2000. We'll go to our board now, and we'll index zeros. And we'll apply that shift from our pivot point. It's going to be right 1600, so there's 1000, 1500. I can make my little reference mark at 1600. From there I go up 2000, 1000, 2000, and this is going to become my target plot. Now I can circle it, label with the 1, and bring it right back over the center. Now up until this point, we do not have our reefer deflection imposed because we do not have a direction of fire or a mounting azimuth. But now I can pull those things. The direction of fire that I have here is 0686. Or rather, that is my azimuth to the target. So with that, I can go ahead and round to the nearest 50. That's going to give us a mounting azimuth of 0700. At 0700, impose my reefer deflection scale. 32, going left 400, right 400. And then begin to pull my chart data for this mission. Come over here, read our deflection as 3214. We'll check our range here. Don't need the range arm here because you already have the vertical center line. And that shows us to be roughly at 2575. The azimuth we already found, that's going to be our direction of fire, so we'll copy that down there, 0686. and we can determine the charge for that given range. We don't have any altitude correction here. We were never given an altitude for the target, so we can move on to that charge. We're firing HE at a range of 2575, which is going to put us into charge 2 in the charge versus range. Now I can find my angle T. I'll take my azimuth, subtract the OT direction, so 0686 minus 0100, and that'll give us 586. Now when I record that, I need to go to the nearest 10, so I'll go 590. And when I send it to the FO in my message to observer, I'm going to send it to the nearest 100, which is going to give me 600. Now I can go into my initial fire command. The mortar to follow, we have a section. Shell and fuse, HE quick. Mortar to fire, since 2 guns adjusting, we got number 2. They're shooting 1 round in the adjust. And we're shooting 5 rounds of procs in the fire for effect. Bring over our deflection, 3, 2, 1, 4. Charge 2. And then we can enter our TFT and pull the requisite information. Charge 2 at a range of 2575 is going to give us an elevation of 1153. Wall and table D, pull my time of flight at 35.4. And then I can flip to my table E and pull my max ord. I'm getting 1526 meters. All right, now we send that information to the gun line. 2 gun fires that round. We will record it and circle it. 2 gun fires. We index our OT direction as we stand by for the correction. And the FO comes back. He says left 100, drop 100. So confirm you are indexed at that OT. Go left 100 and drop 100. And place your plot. Now we can just bring that right back over the vertical center line and pull that chart data for the adjustment. Here I'm reading a deflection of 3224. Correction, 3226. And our range is 2425. We're not in the fire for effect, so mortar fire and method of fire does not change. Don't need to put anything there. We'll bring over that deflection, 3226. Now we got to look at our range. Does 2425 drop us in charge? It does not, so the charge doesn't change. We can leave that blank and just pull the corresponding elevation. Charge 2 at 2425 is going to be an elevation of 1187. We send that out to the gun line. 2 gun fires that round. Now that we've shot, we're going to go ahead and go to our OT direction of 0100. Make sure we're indexed while we wait for our next correction. The FO comes back, he says drop 50 fire for effect. So we'll go ahead and apply that adjustment. And then we'll bring it back over our vertical center line. I can read my deflection. I'm getting 3215. I'm pulling a range of 2400. And now I have my chart data. Mortar to fire, since we're in the fire for effect, we're going to be firing the section. Method of fire, we're shooting 5 rounds procs in the fire for effect, so 5 rounds procs. Bring over our deflection. Our charge, still in charge 2, don't have to put it, but then we do have to change our elevation, so we'll go in at 2400, find the corresponding elevation of 1192, and that's going to be 5 rounds out of 4 guns, 20 rounds for this shot, plus the 2 from earlier, giving us a round count of 22. Circle that after they're shooting. The FO comes back, he says end of mission, estimated 20% casualties, and we're now clear to move on to our next situation. All right, after that last mission, we went ahead and hauled across our target, recorded that last shot that we had, and labeled it with our target number. Moving into situation Bravo, we get a call for fire. It's an adjust fire shift from that previously plotted target. The OT direction 0400, he wants us to go right 600, drop 400. There's an enemy patrol. So we'll go ahead and we'll index that OT direction of 0400. Now that we're here, we're gonna go right 600, drop 400 from Bravo Delta 0500. So grab some sort of reference or count boxes. To make a reference point, and now I can drop 400 from that reference. Place my plot, and then bring it over our vertical center line. All right, looking at our FTC order, section is firing for effect, 2 guns adjusting with 1 round of HE quick, and we're going to do 3 rounds of HE quick in the fire for effect. So now that we know that, go ahead and fill out our initial chart data. Deflection, I'm getting 2902. For range, I'm getting 2275. Our azimuth, 0998. Now at this range of 2275, we're going to be in charge 2, looking at our charge versus range. And now we can calculate our angle T. We're looking at the target at 0998. The FO is looking at it at 0400. So subtract that and get an OT direction, an angle T of 598. When I record that to the nearest 10, that's going to be 600. And I'm going to send it to the nearest 100. It's already there. So I'll send angle T as 600. Now for our initial fire command, mortar to follow is the section. Firing HE quick. Mortar fires number 2 gun, and they're doing 1 round in the adjust and 3 rounds in the fire for effect. Bring over our deflection of 2902 at charge 2, and now we can pull our elevation, time of flight, and max ord. Going into table D of charge 2 for a range of 2275 is going to be an elevation of 1218. Time of flight of 36.6. And flipping over to table E, we can get our max ord of 1604. We send that information to the gun line, 2 gun shoots it. We can circle that round and record it, and then index our OT direction while we await our correction. So we're at our OT direction. The FO comes back, he says left 200, add 200. So we'll go ahead and make that correction from our previous plot. Once we have that plotted, we can bring it back over our vertical center line and pull our chart data. For deflection, I'm getting 3024. For range, I'm getting 2350. We're still adjusting, so no change to mortar fire or method of fire. We just bring over our deflection of 3024. At a range of 2350, we're still in charge 2, so no change to charge. And our elevation corresponding to that is going to be 1203. We send that info out, 2 gun shoots, we record and circle it, and then go back to our OT direction, awaiting our correction. The FO comes back, says drop 100. So we just make that adjustment. And bring it back over our vertical center line. Now I'm getting a deflection of 3003 and a range of 2250. Still adjusting, so we'll just bring over our deflection of 3003 and pull the corresponding elevation of 1223. We send that information out. 2 gun shoots their round, and we can go back to our OT direction. The FO comes back, he says add 50, fire for effect. So we'll go ahead and make that adjustment. And bring it over the vertical center line. Start by pulling our chart data. I'm getting a deflection of 3013 at a range of 2300. Now our mortar to fire is going to change since we're in the fire for effect. We have a section. They're firing 3 rounds of HE quick, so just put 3 rounds. Deflection of 3013, and at 2300, we're still in charge 2, so no change there. We can just pull the corresponding elevation of 1213. 4 gun shooting 3 rounds is 12. Add the 3 from before, and that puts us at 15 rounds expended. They shoot, we circle, and the FO comes back and says end of mission, estimated 30% casualties. At this point, we can record that target with our holocross on the final adjustment that we made and move into our next situation. All right, moving forward, we see that we have a new data sheet and that we've moved to a new location. That said, we can sanitize our board and go ahead and begin setting this up. We'll also notice we have a GI now, and they want us to do a modified observed. So I like to start by just recording everything that's on this data sheet. My GI is 1682. My MFP grid is going to be 1527, 8018, and I'll tack on a 0 at the end of both of those in order to get a 10-digit grid. Now it gives us an altitude of 550. A mounting azimuth of 6200. And a reefer deflection of 2800. We also have a forward observer data. So we have Alpha 61 located at grid 1452, 8267, and add 0s on the end to make it a 10-digit grid. His altitude is going to be 595. So now I'll move to my plotting board and set up my modified observed chart. First thing I need to do is index 0 and superimpose the map onto the plotting board. First 2 numbers of my GI is 16, so I'll go from the pivot point, drop down 2000, and place my 16. Second 2 numbers is 82, so I'll go from my pivot point left 2000 and place the 82. From here, every 1,000 meters I can increase or decrease relative to which way we're going. As you move up the board, the numbers go up for your northings, and as you go down, they go down. For our eastings, as we go left, they decrease. So every 1,000 meters, I'll decrease by 1. And as I go right, they'll increase by 1. So now I have the map superimposed on my board. I can plot my MFP and my FO just as I would as a normal nav. So I go to my 1, 5, 1, 5, 1, 1, 5, 2. And since my grid is 1, 5, 2, 7, I know I'm before this third line. So I'm going to be somewhere in the middle here on my MFP easting. Now my northing is 8, 0, 1, 8. So we'll go 8, 0 right here, 8, 0, 1. And I know it's going to be somewhere in between these boxes. Place my plot. And that is our MFP at an altitude of 550. Now we'll plot our FO. Our FO is at 1452, 8267. So 1482. He's going to be somewhere in this grid square. 145. And just a little past before that next green box ends, he's going to be somewhere in here on the easting. Now for the northing, he's at 8267. So 82825, 826. And I know he's going to be somewhere up here between the third and the fourth green box. So I'll place him down. And I'll draw my triangle around it, give his ID off to the right side, and his altitude below it. Now we're almost done setting up our board. We just need to go to our mounting azimuth of 6200 and put our reefer deflection scale. 2800 at 62, left 400, increasing as we go. And then right 400, decreasing as we go. You confirm on our data sheet that we're not forward plotting anything. We have our FO plotted and our MFP, our reefer deflection scale superimposed, as well as with our GI. So we can go ahead and move on to the next situation. All right, moving into situation Charlie, Alpha 61 calls and adjusts fire polar, gives us his direction, his distance, and then a vertical interval of up 625. Actions on the plotting board. We'll go ahead and index that OT direction of 6400 or 0000. We'll get our range arm and we'll go at a distance of 1100 straight up the board, parallel with the FO, and place our target plot. So 1100 meters, straight up and parallel with our FO. We'll go ahead and place that plot, and that becomes our target. We can now parallel plot our MFP with that target. Now that I'm parallel plotted, I'll go ahead and just pull my chart data. I'm getting a deflection of 2814. Use my range arm to pull the range of 3675. And an azimuth of 6186. Now we have to look back at our qualifier here and determine the altitude of this target. The FO is saying up 625 in relation from himself. So we'll go ahead and take the FO's altitude of 595. We'll add 625, and that's going to give us an altitude to this target of 1220. Now we got to determine our VI and our altitude correction. To get our VI, we'll take that 1220 and we'll subtract our MFP's altitude of 550, since we're lower than them, to get a vertical interval of positive 670. Divide that in half, and that'll give us a positive 335 altitude correction. We'll take our chart range of 3675, add in our altitude correction of 335, and that's going to give us a new range of 4010, rounded to the nearest 25 will give us 4,000 for range. Look at our chart versus range. Charge versus range scale says that we are going to be in charge 3. So we'll record that there. Now we can determine our angle T. The FO is looking at this at 6,400. We're at 6,186. So we'll take the FO's OT direction minus our azimuth to the target. And that'll give me 214 for my angle T. Rounded to the nearest 10 is going to be 210. And since it's not in effect, we don't have to send it out to that FO. Now we can move to our initial fire command. We have a section to fire for effect. So the section is following. Shell and fuse, we're shooting HE quick. Mortar to fire is 2 guns since they're adjusting. And they're adjusting with 1 round in the adjust. And we're going to do 5 rounds of procs in fire for effect. Bring over our deflection to 814. We determine charge 3. And now we'll pull the corresponding elevation for our adjusted range. Go to table D at charge 3. Find the corresponding range. And at 4,000, our elevation is going to be 1055. For our time of flight, 40.1. And then flip to table E so we can get our max ord. 1949. We send that information to the guns. 2 gun shoots it. We can record it and circle it. And now we'll index our OT direction while we await that FO correction. Now that we're here, the FO says left 20, add 100. So we'll go ahead and apply that to our previous plot. Place that plot, give it a circle, and now bring it back to parallel with your MFP in order to pull your chart data. Now I'm getting a deflection of 2811. And we can't forget here, before we pull our chart range, to bring down that altitude correction. That just serves as a reminder that we're going to be getting a different command range. So now that I've brought that down, I'll go ahead and pull my chart range. I'm getting 3775. We're still adjusting, so no change to mortar fire, method fire. Bring over that deflection of 2811. Give our new adjusted command range, or rather our new command range, which is 3775 plus 335, giving us 4110. Round that to the nearest 25, and that is 4100 for our command range. 4100 still allows us to be at the lowest charge of charge 3. No change to charge, so we just pull the corresponding elevation for that of 1032. We send that to the guns. 2 gun shoots it. We record it and circle it. And now we can move on to indexing our OT direction while we wait for our correction. Standing by at the OT direction, the FO comes back with left 20, drop 50, fire for effect. So we'll go ahead and apply that now. Place your plot, and then get it back to parallel with your MFP. Now I'm pulling a chart deflection of 2818. We'll check our chart range. And I'm getting 3750. For our subsequent commands, now that we're in the fire for effect phase, we are going to have the section firing. They're going to do 5 rounds prox. Bring over our deflection to 2818. Calculate our command range. So 3750, which is our chart range, plus our altitude correction of 335. Gives us 4085. Round that to the nearest 25, and that'll be 4075. Pull the corresponding elevation of 1038. That's 5 rounds out of 4 guns, so 20 rounds for this iteration, plus the 2 from earlier. That gives us 22 HE expended. The FO comes back. He says, end of mission, estimated 10% casualties. We're now good to erase all of our adjustments except for the final one, haul across it, label it, and give it its altitude. Once we're there, we can go ahead and move on to the next situation. All right, moving into situation Delta, we get a call for fire from Alpha 61. He says, adjust fire shift from Bravo Delta 0502. He gives us his OT direction, his right drop and down corrections, and says that we have a machine gun nest. So we'll go ahead and apply those corrections now, starting with our OT direction getting indexed. We'll index that OT, and we'll make those corrections from Bravo Delta 0502. The FO wants us to go right 200, drop 200. So you can either count boxes or use a reference, like your range arm or protractor. Place your plot, and then bring it nice and parallel with your MFP. Now I can pull some chart data. We have a deflection of 2757. With an azimuth of 6243. Now we can pull our chart range. I'm getting 3550. Now I like to look at our altitude correction for this. We have down 150 from our previous target, which was at 1220. So we'll take 1220, subtract 150, and that's going to give us this new target altitude of 1070. At this point, I could determine our vertical interval by finding the difference between the target altitude and our MFP's altitude. So I'll take that 1070, subtract our MFP's altitude, and that's going to give us a positive 520 for our vertical interval. Check that it's positive for our altitude correction, divide that by 2, and we'll get an altitude correction of positive 260. Now I can add that 260 to my chart range of 3550, and that'll give me a command range of 3810, rounded to the nearest 25 is going to be 3800. At 3800, looking at my charge versus range scale, I will find that I'm in charge 3. So now I can calculate my angle T after I record that. My direction to the target is 6243. The FO is at 6100. So I'll do 6243 minus 6100 to get my OT direction, my angle T of 143. I'll record that to the nearest 10, and it's not in effect, so we don't have to send it. Now I can move on to my initial fire command. The mortar to follow is going to be a section. My shell and fuse, we're firing HE quick. Mortar to fire number 2 gun, since they're adjusting, and they're adjusting with 1 round in that adjust phase. We're firing 2 rounds in the fire for effect. And now we can bring over our deflection, 2757, bring over our charge of 3, and pull the rest of the data. Go to table D at a range of 3,800, and that'll give us an elevation of 1097. Our corresponding time of flight is 4100, correction 41.0, and then we can go to table E and get our max ord of 1899. We send out that data to the guns. Correction on that max ord at 3,800. Our max ord is 2035. Now we can send that data to the guns. 2 gun will shoot it. We record it, circle it, and we can stand by at our OT direction of 6100 while we await that correction. So standing by at our OT direction, we're gonna apply these corrections that the FO gives us. He says left 50, add 50. So we'll just go and apply those to our previous plot. Go left 50, add 50. And the FO also says we're firing for effect, so we know we are in the final phase of this. We'll go ahead and parallel plot that target with our MFP and begin pulling our chart data. The deflection I'm getting is 2773. For our chart range of 3,600. And we can't forget to bring down our altitude correction from earlier. So I'll just write my reminder there. Now, since we're in the fire for effect, we have a section firing. Our method of fire, we're doing 2 rounds of HE quick. We'll record 2 rounds. And now we got to pay attention to this FDC order. We notice that we're converging on 2. So we know we're going to have to give each gun a different azimuth. So I'll go ahead and record all the guns and put our chart deflection down for 2 gun. Now I'm going to need to determine what all the other deflections are, and the way I'll do that is by going to my deflection conversion table. I will enter in at my final chart range of 3,600, and with the gun spaced 40 meters apart, find where those 2 intersect, and I'm getting a shift of 11. We've got 1, 2, 3, 4 gun, 2 guns hitting here, 1 gun needs to go left, 3 gun needs to go right, and 4 gun needs to go right twice. So I'll take my deflection for 2 gun, and if I want to get 1 gun's deflection, I'm going to have to add 11, because working with deflections, left add, right subtract. Add that into it, and that gives me a deflection for 1 gun of 2784. Now I could take 2 guns deflection, subtract 11, and that'll give me 3 guns deflection, 2762. I can then subtract 11 from 3 guns deflection to get 4 guns deflection of 2751, or I can take 11 times 2 and subtract that 22 from 2 guns deflection of 2773, and that'll give me the same answer. All right, so since we have an altitude correction here, we have to apply that and come up with our command range. 3,600 plus 260 is going to give us 3,860. We round that to the nearest 50, and that'll be 3,850. Now I can just pull the requisite elevation. We're still in charge 3, so we can just go into the TFT. At 3,850, our elevation will be 1087. We have 4 guns firing 2 rounds each, so that's 8, plus the one from earlier gives us 9 HE expended. The FO comes back, says end of mission, target destroyed. We can go ahead and record that target with our holocross and move on to the next situation. All right, so the next page you open up to, you'll see that you have a data sheet and they are instructing you to create a surveyed firing chart. So just like I always do, I like to go ahead and copy that information down onto my board so I have it for reference later. We've got a GI of 1480. Our MFP is located at 1398 7807. And we'll just tag zeros on to the end of those to make them 10-digit grids. Gives us an MFP altitude of 530. Does not give us our mounting azimuth, but it does give us a reefer deflection of 0700. So now we'll go ahead and set this board up. Index 0. Drop 2000 from the pivot point. Marker 14. Go 2000 left of the pivot point and mark our northing of 80. From there, we're just filling out the board as if it were a map. 13, 12, 15, 16. We can just place our MFP on here, pretending that this is a map, doing it the same way you would. So we got 13,980 for our easting, and our northing is 78,070. So I'll go 13,9, and I know 80 is going to be somewhere about halfway into that last green box. 78,070 is going to be just past this first green box on the northing and almost halfway in between with that second. So I'll go ahead, place my plot. I can go ahead and record that as my MFP. Give it a holocross. And we'll place our altitude down there on the bottom left. They also give us a grid to RP1 down here in our target data. So we can go ahead and plot that now. Got 1561, so I'll go 15, 155, 156, and just a little bit past gets us to 1561. Now for our northing, we're at 8003, so we'll follow this all the way up to 80, and 03 is going to be about halfway in this box here, in this first green box. So I'll go ahead and just place my plot there, give it a holocross to record it as RP1. Give us an altitude of 600, so we'll place that down in the lower left. And since we have a registration point, we can actually go ahead and pull our mounting azimuth and direction of fire for that just by going ahead and parallel plotting that RP with our MFP. Get it all parallel. I'm pulling a direction of fire of 0710. So that's going to be our direction of fire, 0710. And that means our mounting azimuth is going to be 0700. Now we can impose that reefer deflection scale, going left 400 from our mounting azimuth and right 400 from our mounting azimuth. We now have our board set up and we can move on to the next situation. Moving on to situation Echo, we are instructed to conduct a registration mission for the grid that we've already plotted as RP1. we inform Alpha 60 and he sends the following mission. So now we're going to conduct that. Now, one of the things I like to start off with, just so I don't forget it later on, is anytime you're dealing with registration, you have to let the observer know in a message to observer, prepare to register. So off rip, I like to just put my MTO, prep to reg, RP1. Now, since I already have this parallel plotted from setting up my board, I will leave it there. We already pulled our direction of fire, which was 0710. In other words, that's our azimuth to that target. So now we can read our deflection of 0690 and pull our chart, initial chart, range for it. I'm getting 2550. Now we can't forget that we have to determine our altitude correction here. So I'll start by taking a look at the altitude for this target of 600. Our altitude is 530, so I'll go 600 minus 530, and that would give me a vertical interval of positive 70. Divide that by 2, and that's going to give us a positive 35 for our altitude correction. We add that 35 to our 2550, and that's going to give us a new command range of 2585. Once we round that to the nearest 25, that'll be 2575. Looking at our FDC order, seeing HE quick for the round type, going to our charge versus range. At the command range of 2575, we are in charge 2. Now let's calculate angle T. Take our azimuth of 710, subtract the OT direction of 0500, and that's going to give us an angle T of 710. It's not in effect, so we won't send it, and we can go ahead and get into our initial fire command. So we have a section following. They're firing HE quick. Number 2 gun is the adjusting. And notice we have 1 round in adjust, none for the fire for effect. So all we're going to put here in method of fire is 1 round. Carry over our deflection, 0690, our charge of 2, and then we'll go into the TFT and pull the requisite information. At a range of 2575, our elevation is 1153. While in table D, I'll pull my time of flight of 35.4. Then flip to table E to pull my max ord. We send that information to the gun line. 2 gun shoots it. We can record it, circle it, and then index our OT direction while we stand by for our correction. The FO comes back, he says right 20, drop 50. We'll go here. And we'll apply that correction. Bring that new plot parallel with our MFP. And begin pulling our chart data. For our deflection, I'm pulling 0681. I'm going to not forget to bring down this altitude correction here, just so we have a reminder that after we pull this chart range, we're going to have to factor that in. To pull our chart range now, and I'm getting 2500. Order fire method fire does not change since we're still adjusting, so we'll bring over that deflection of 0681. Pull our new command range. 2500 plus 35 is 2535. Round that to the nearest 25, and we will get 2525 as a command range. Go and pull our corresponding elevation. Still in charge 2. That's going to be 1165. We send that information to the gun line. 2-gun shoots it. And now we can stand by at our OT direction while we await our correction. The FO comes back, says drop 2-5, end of mission, registration complete. So we'll go ahead and make that adjustment. Bring that new plot parallel with our MFP to pull our chart data. All right. Looking at my chart deflection, I'm getting 0.680. And for range, I'm pulling 2475. Now everything up to now has been pretty much a straightforward normal mission, and this is where registration kind of comes into play. Since it's a drop 2-5 and a mission registration complete, we know 2-gun is now hitting where we want them to. We're going to adjust the sheaf at this point. So we don't have any round expenditure. We're not actually shooting on this line. We're waiting for the FO. He comes back and he says section left. So that tells us he wants us to fire the guns in order of 4, 3, 2, then 1 as a section left. But since 2-gun's already adjusted, we're not going to have to fire 2-gun. So we'll go ahead and format our subsequent commands. We now have a section firing. They're going to do 1 round, section left, but we're going to let number 2-gun know, do not fire. So 1 round, section left, number 2-gun, do not fire. And then we'll just bring over our new chart deflection, 0680. Give the new command range, 2475 plus 35 is going to be 2510. Round that to nearest 25, and that gives us a command range of 2500. Still on charge 2, no change there, so we'll just pull the corresponding elevation. At 2500, our elevation is going to be 1170. Now we have 3-gun shooting right here, since number 2-gun is not firing. So 3 rounds plus the 2 from earlier. Now we're at 5 rounds expended. Now the FO comes back. He says number 3-gun needs to go right 40, and then the sheaf is adjusted. So formatting for this, we're going to say, hey, number 3-gun, do not fire. Since this adjustment is less than 50, we do not have to fire another round. And now we have to compute the deflection for number 3-gun. So we'll come over to our our deflection conversion table. And since we're now working with a surveyed firing chart, we are going to go in at our initial chart range when determining our shift here. So they need to go 40 meters to the right, which means we have to go in at 40 for our column. And then for our row, we're going to round this 2550 to the nearest 100, 2600, and find where the 2 intersect. The number that we're pulling from our deflection conversion table is 16. So we need to adjust the deflection by 16 for 3-gun to be hitting where they're supposed to. So we'll take, since we need to go right, we're going to go 2-gun's deflection of 0680. We're going to subtract 16, once again, because we're going right. With deflections, you right subtract. And that's going to give us 3-gun's new deflection of 0664. Once again, they're not actually firing this round, so we don't have to give a command range or elevation. We're just telling them to get the gun onto this deflection. And now since the sheaf is adjusted, we can go ahead and refer the section. So we'll go section, refer the last hit deflection of 0680. And then we could tell them realign, aiming, post. At this time, 3 gun's gonna notice that their sight picture's a little off, so they're gonna relay in their poles, and then everyone is gonna have a pretty sheaf. Now we have to go into finding our deflection correction, otherwise known as DEF-K, our range correction, and our range correction factor. For registration, we're going to be comparing for deflection our initial chart deflection and our final chart deflection. We have an initial of 690, a final of 0680, subtract the 2, and we're going to get a DEF-K of 10. Now to determine if it's right or left, remember, we have to subtract if we want to go right, add if we want to go left. In this case, we would have had to subtract 10 from our initial chart deflection to get our final chart. So we know it's going to be a right. We did the math to get the 10. We determined it was right. Our DEF-K is right 10. Now for range correction, you're going to be comparing your initial chart range to your final chart range. So we'll take 2550, we'll subtract 2475, and that's going to give us 75. Now, since our initial chart range is greater, we would have had to subtract 75 to get to our final chart range, so it's going to be negative. Now we need to find our range correction factor. We'll do that by going to our initial chart range of 2550, and we'll round it to the nearest 100. In this case, that would be 2600. So now we're going to divide that by 1,000 or express it in thousands. So 2600 becomes 2.6, and we'll divide our negative 75 by that 2.6. So negative 75 divided by 2.6 is going to give us a range correction factor of negative 28.8, or more simply, negative 29. At this point, we now have our DEF-K, range correction, and range correction factor. We have referred the section and realigned their aiming post, and we are complete with our registration mission at this time. The FO once again tells us registration complete, chief adjusted, and we can move on to the next mission. All right, moving on to situation F, we have an adjust fire shift from RP1, given our OT direction, a right, an add, and a down, and it says that we have a platoon in the open. You'll notice as well that we now have a basis for correction, which is RP1. So we're going to be applying our deflection correction and our range correction factor in order to find our total range correction. Now, for exams, you're going to be given a new DEF-K and a new range correction factor. So I always recommend, once you hit this part of the team drill, you go into the answer key and you pull the deflection correction and the range correction factor that they have in the answer key, just so that you're still macking with all the answers that they have. In this case, they are giving us a deflection correction of right 15, a range correction factor of negative 29. And now we can go ahead and get started with this mission. All right, so getting into it, since we're on a shift mission, we're going to go ahead and index our OT direction of 0720. We're going to apply those shifts from our registration. The FO wants us to go right 300, add 700. So use a reference point, count boxes, whatever makes you happy. I reference mark it right 300, then add 700. And this becomes our new target plot. We can now bring it parallel with our MFP and begin pulling our chart data. Initial chart data, that is. Okay, I'm pulling a deflection of 0.595. A chart range of 3275. And the corresponding azimuth of 0805. All right, we are given somewhat of an altitude correction here. We have down 120 for our registration point. So we'll look at our registration point's altitude of 600, and we'll subtract 120 from it. That's going to give us an altitude to this target of 480. Our MFP is at 530. The target is at 480, so we'll go 530 minus 480 to get us a vertical interval of -50. Divide that by 2, and that'll give us our altitude correction of -25. Now we also have to come up with our range correction. How we're going to do that is we're going to take our initial short range, we're going to round it to the nearest 100, and then express it in thousands, just like you did when you were calculating the range correction factor. You're just going to do that to this initial range here. So 3275 goes to 3300, expressed in thousands is 3.3. And then we're going to multiply that by our range correction factor of -29. That will give you your range correction. So 3.3 times -29 will give you a -95.7, or in other words, -96. We'll combine our range correction with our altitude correction, and that will give us a total range correction of -121. Now we also can't forget, since we're working with our basis correction of RP1, to bring down our deflection correction. We are giving a right 15, so we just have to make sure whenever we bring over our deflection to the fire command, we apply that right 15 to the deflection. Getting back into our range here, we got to find our command range, so we'll take 3275, we'll subtract our 121, which is our TRC, and that'll give us a range of 3154, rounded to the nearest 25 is 3150. Since we're using HE, look at our charge versus range, and that's going to put us into charge 2. Now looking for angle T, we are at 0805 for our azimuth to target. The OT is 0720. That's going to give us an angle T of 85. We're going to write that down to the nearest 10 of 90, and since it's not in effect, we don't have to send it. Now getting into our initial fire command, we have a section to follow. Number 2 gun, so we're firing HE quick for shell and fuse. Number 2 gun is adjusting with 1 round in the adjust. We have 3 rounds of procs and fire for effect. And now for our deflection. Once again, we have to remember to apply our def K. So we'll take our original deflection of 0595. We'll subtract 15, right, because it's a right. And that's going to give us a new deflection of 0580. We already determined we're in charge 2 and that our command range is at 3150. So we'll just pull the corresponding elevation, time of flight, and max ord for that. 3150 gives me an elevation of 0994. Correction, 3984. Pull our time of flight, 32.4. Going into table E, so we're going to get our max ord, 3150. Our max ord is 1275. We send that information to the gun line, 2 gun shoots it, we record it, and now we're standing by at our OT direction while we await the FO's corrections. He comes back, he says, right 50, add 55 for effect. So we'll go ahead and apply that shift now. And we can bring it parallel with our MFP in order to pull our chart data. Now I'm getting a deflection here of 0.580. And just like before, we're gonna have a def K that we have to remember to bring down. So I'm gonna drop it there. We're also gonna have to bring down our total range correction of 121 minus 121. And now I have reminders here for when I go to our subsequent command. Pull my chart range. I'm getting 33.25. And now I can work on filling out my subsequent command. We're in the fire for effect phase now. So now I know I'm firing this section and they're doing 3 rounds of procs. So mortar to fire section, method of fire 3-round procs. For our deflection, we'll take our chart of 0.580, we'll subtract the 15, and that'll give us 0.565. Now for our command range, we're going to take 3325, apply our altitude correction of -121, and that'll give us 3204, round to the nearest 25, and we have 3200. That still keeps us in charge 2, so no need to put a charge there, but we'll go into the elevation and pull for 3200, 0963. 4 guns shoot 3 rounds each, that's 12, plus the 1 from earlier gives us 13 HE. The FO comes back, says end of mission, estimated 30% casualties, and we can go ahead and record that target on our board and move on to the next situation. All right, moving on to situation golf, our final situation. We are going to be doing a re-registration mission on RP1. Now for initial chart data, obviously this target hasn't changed. We have all the initial chart data already. So to make things a little bit faster, we can look back at our registration mission and just pull over our chart information. So we have a deflection of 0.690. We have a range of 2550. Our VI was plus 70, giving us a plus 35 for altitude correction. Our azimuth was 0.710. And since our OT direction did not change, we still have an angle T of 210. Now notice I did not put our new range or the charge. I did not carry that over because you'll see we also are using a basis of correction from our registration point 1, aka we're going to bring over our deflection correction and our range correction, applying our total range correction in order to get our firing data. So once again, we have a right 15 for our def K. Our range correction factor was -29. We also have a range correction of -75. So I'll just go through the math here so we can see if we did -29 times 2.6, because this would round to 2600, becoming 2.6. -29 times 2.6 gives us -75.4 or -75. You can do it either way. I would just recommend using that range correction that they give you because that's designed for your re-reg. So in either case, we have a range correction of -75. Combine that with our positive 34, or 35 rather, and that's going to give us a TRC of -40. So now I can apply that to my chart range. 2550 minus 40 is going to give us 2510. Round that to the nearest 25, and we're at 2500 for our command range. That's going to put us in charge 2, looking at our charge versus range. And then we can go into our initial fire command. We have number 2 gun. Notice how this has changed now too, because in registration, we were adjusting the entire section, adjusting the sheaf, so we had to fire the entire section. For re-reg, we're only shooting 2 gun, and then we're just getting our new corrections. The sheaf is already adjusted, we don't need to redo that. So mortar falls number 2, shell infuses HE quick. We're gonna fire 1 round. For our deflection, we can't forget to apply our deflection correction, so 0.690 minus 15, that'll give us 0.675. charge 2, and now we'll enter our TFT and pull the information we need. At a range of 2,500, our elevation is 1170, time of flight 35.7. Flip to table E and grab my max ord of 1548. We send that information out. Two gun shoots it, and now we're standing by at our OT direction while we await our FO correction. FO comes back, says left 50, add 100. So we'll make that shift from our initial plot point of RP1. Go left 50, add 100. Now keep in mind that you're not going off of that final shot that you did on registration. You're going from the initial plot of that registration point. When you do finish with registration, you should erase all those correction shots. You should only have your initial plot for RP1. The surveyed firing chart, you know for sure that that target is where they're saying it is. So all those other adjustments can be erased. That way, when you get to something like this in re-reg, you only have that initial plot. Anyway, after we go ahead and make our shift, we'll bring it back to parallel with our MFP. And begin pulling our chart data. Chart deflection, I'm getting 0.719. And for my chart range, I'm getting 2650. Now I can't forget to bring down my def K and my TRC. So we got a range correction of -40 and a def K of right 15. No change in mortar to fire method of fire. Our deflection, however, we have to apply that right 15. So we'll take 0.719, subtract the 15, and that'll give us 0.704. Get our new command range. 2650 minus 40 is 2610. Round to the nearest 25 is 2600. And we're still in charge 2. So we'll just pull the corresponding range, or elevation rather, of 1147. Two gun shoots that round. We can circle it and go back to our OT direction while we stand by for corrections. The FO comes back, says drop 50. So we go ahead and apply. And bring it back to parallel with our MFP. I'm pulling a deflection here of 0.715. With a range, chart range of we'll go 2600. Order to fire doesn't change, neither does method. So now we're just applying our corrections to our chart data. My deflection becomes 0.700. My command range, 2600 minus 40, puts us at 2560. Round that to the nearest 25, and that'll give us 2550 for our command range. Corresponding elevation is 1159. So we'll give that to the guns. Two gun shoots it. And then we can go back to standing by at our OT direction. Now we're here. FO says drop 25 and emission. So we'll go ahead and make that plot. And bring it parallel with the MFP to pull our chart data. The deflection I'm pulling is 0.714. At a range of 2550. Now, because it was only a drop 2.5, we do not have to refire that. So we're just going to compute that data and give it to Two Gun as a do not fire. So mortar fire obviously doesn't change. We're just going to tell them do not fire. Our new deflection for them, 0.714 minus 15 is going to be 0.699. 2550 minus 40 is 2510, giving us our command range of 2500. And then pull the corresponding elevation if we were firing, but since we're not here, we don't have to put anything. And obviously, there's not another round shot. Now we have to come up with our new def K, our new range correction, and our new range correction factor. To do so, we're going to be using a different formula than for registration. We're going to be comparing our initial chart data to our final command elevation, or deflection rather, as well as an adjusted command range. So we'll start simply by comparing our initial chart deflection to our final command deflection. Our final command is 0699 rather. Our initial is 0690. So in order to get to our final command, we would have to add 9 to our deflection. So that gives us a def K of left 9. Our initial chart is smaller than our subsequent command deflection. So we know it's a left, and we just find the difference there of 9. We have a def K of left 9. Now we have to determine our adjusted command range. To do so, we're going to invert the sign of our altitude correction and apply it to that command range. So in this case, we'll take our command range of 2500. We had a positive 35 altitude correction, so now we're going to subtract 35 from that command range. And that gives us an adjusted command range of 2465. We'll compare that with our initial chart range, 2550. So 2550 minus 2465. And that's going to give us a difference of 85 for the range correction. Now with that range correction, we're going to look, is it positive or negative? This is our initial chart. It is larger than our adjusted command range. Therefore, we would have had to subtract to get here. So that's going to be a negative. Now, to get our RCF, you're going to use the same formula as for registration. We'll take that negative 85 and we'll divide it by this rounded to your initial chart range, rounded to the nearest 100, and then expressed in thousands. So 2550 rounds to 2600, expressed in thousands is 2.6. So we'll go negative 85 divided by 2.6 to get a new range correction factor, a negative 32.6, or in other words, negative 33. At this point, you have your new def K range correction factor, and you are complete with re-registration. You can erase all those adjustment rounds that you just fired and go ahead and move on to updating your data sheet with the new corrections that you have, or in this case, being done with the team drill and being happy with yourself.